Okay, so projectile motion. We have a question which you can find in the description of the video, but basically a golfer hits a ball at 20 meters per second along the horizontal and is elevated 4.9 meters above the ground. So question A, how long after the ball leaves the club will it land on the fairway? Well, let's fill in a couple of bits of information first. The ball is going to do this and strike a distance, we'll call it R, away. No matter where we measure the horizontal velocity along this path, it's always going to be 20 meters per second. Always the same, 20 meters per second. It accelerates along the vertical, and its acceleration, not its velocity, is always the same at 9.8 meters per second squared. So this will actually get faster and faster as it accelerates as it goes along. So we'll have two components eventually, the horizontal, which always remains at 20, and the vertical, which will continue to get faster because it accelerates. No acceleration for horizontal because we just imagine it moving horizontally along the ground, so no acceleration. First question is, how long after the ball leaves the club does it hit the ground? Well, in this direction, it's traveling on at 20 meters per second, but it is accelerating downwards. So we can use that again. We know this. This is going to be 4.9 meters. We know this to be 0 because it wasn't moving along the vertical when it was hit, just horizontal. This, no need. This, 9.8, and this, we don't know. So we're going to use S equals UT plus a half AT squared. 4.9, this is 0 plus a half times 9.8 times t squared. You rearrange this to find that 4.9 times 2 over 9.8 equals 1 second. Now if it was travelling for 1 second, which is the answer to A, if it was going along here and it's travelling for 20 meters per second at 1 second, then R must be 20 meters. As it's not accelerating, we can use speed equals distance over time, where distance equals speed times time. So it's 20 times 1, which is just 20. That's the answer to A and B so far. Now, we're going to do C. What is the acceleration of the ball 0.5 seconds after being hit? Well, the acceleration is always the same for vertical motion. It's always gravity, so it's always going to be 9.58. Very easy question. Calculate the speed of the ball 0.8 seconds after it leaves the club. Now, when it gets 0.8 seconds later, say it's about here, it's going to have a horizontal motion and a vertical motion. We need to find out what the vertical motion is before we can resolve these two to find our resultant. So what is this? Well, we can go V equals U plus AT. This is part D. In this case, V equals 0, again, plus 9.8 times 0.8, which equals, I think that is 9.8 times 0.8, 7.84. That is this, 7.84 meters per second. Notice we have two though, we have vectors, so let's resolve them. So this is what we're looking for, this is the true speed. So x equals 20 squared plus 7.84 squared. So this would be 20 squared plus 7.84 squared. And then we square root that, 21.5 meters per second. That's the speed at this point, because it has two vectors. So I've got this speed. E says, what's the speed when it hits the ground? So what's the speed at this point? Well, this must have got faster because it's had an extra 0.2 seconds to continue. So we know it takes 1 second to do this distance. and this was at 0.8 seconds. So we'll have to do both now. So we'll have to do this again, where this is plus 9.8 times 1. So now this is 20, and this, when it hits the ground, is 9.8 meters per second. So it's exactly the same calculation as we've just done. Square root of x, which is the resolution of those forces, equals 20 squared plus 9.8 squared. So this would be 20 squared plus 9.8 squared, square root that, 22.3. I'm going to check that I've got that right. 0.8 seconds, it was 21.5. 1 second, it has got faster, which makes sense, at 22.3. Okay. Feel free to ask any questions in the comments, and I'll post some harder ones as well.